So what you're going to do today, I've kind of learned in this modeling, sometimes y'all don't really, okay, you're not going to do assignments until the night before. And so you're not going to really learn material as we go along unless I make you do stuff. And however, you know, when we're doing these models and I'm posting OP and you're copying me, it may seem logical when you're following me, but then when you have to do something on your own, it can be totally different. And so I'm making you construct your model on your own today. Of course, I'm going to come around and help, but you've got to struggle through it yourself, because I find if I don't make you struggle, you don't do well. You will need this model because there'll be an assignment where you have to answer questions about that model. So you want to have it working well, and you're going to have to do it. And of course, you can use each other for help. And I'm going to get us started off with the terminology. So what we're going to be doing with this model, it's the same model we dealt with before. You're producing gum, you can store it as inventory, and you have to make sure you can have enough to meet a certain demand every month. And it's the same months, March through July. The difference now is that we have two different types of gum. So I've given you a starting place. This place where we decide how much of gum 1 we're going to produce. So X1 is gum 1. How much inventory of gum 1 we're going to have at the end of each month. Then how much of gum 2 we're going to produce, and how much inventory of gum 2 we're going to have. So this is very much like your previous models, except there's more than one type of gum, but the basic logic of the model will be the same, and there will be one additional constraint, as you'll see. I can't get the big thing working, but you've got the worksheets, right? And we're going to, first thing it does is we're talking about the model itself. And so what we're doing here is you run a factory that produces two types of gums, X1 and X2. So whereas before X just referred to a gum you produce, now you have gum 1 and gum 2. In that table below, I show you the storage cost and the production cost of each gum. So C2I, I refers to months, so if I is 2, that means April. C2I means the cost of producing 1 unit of gum 2 in April is 3. We have a storage cost. For gum 1, it's always 10 in every month. So anytime you have ending inventory, a unit of ending inventory in a month, you're charged $10. And then we have demand. So demand 1 is 300 for each month for gum 1. But for gum 2, demand in March is 300, demand in April is 500, and so on. The first set of questions is to help us make sure we understand the structure of the model. Okay. And number one is saying, what are the decision variables? Okay, so help me here. What kind of things are we asking the computer to decide? What is within our control? What, Stevie Ray? How much to make and what? Yep. So, two of our decision variables are x1i and x2i. So we have to decide it for each month. We got the I there saying we also need to make that decision for each month. How much of each gum to make in period 1, how much of each gum to make in period 3, and so on. Notice we are also deciding how much to keep in inventory. That's another decision variable. And remember, we're organizing the spreadsheet such that our decision variables are always going to be on one single row. We do it because it helps us organize our thoughts. We do it because it makes a convenient use of the sum product formula. Then we have number 2. What are the parameters or coefficients? This is something I haven't even talked about. But parameters or coefficients, that's any time you're given something that's a number and it's not something you have any control over. So the per unit cost in each month, I give it to you, that's a parameter. The per unit holding cost, I give it to you, that's a parameter. The demand in each month, I give it to you, that's a parameter. And so those are all our parameters and coefficients. If I added something else like shrinkage and we said shrinkage was 10%, that's a parameter. Anything I give to you. And again, there's an I subscript because those numbers can differ for every month. They don't have to, but they can differ for every month. Okay. For the objective function, we know we want to choose, we know our decision variables, how much to produce each month, how much to store each month. And we're choosing those to do what? What is the goal we're trying to achieve? Minimize cost. All right. And the way we usually write this, usually I do this on the overhead. Someone sabotaged it. We're going to do this. So we're minimizing some function. We're minimizing by choosing x1i x2i I1i and I2i. We formulate like this to make sure we know exactly what we have control over. And then we're trying to minimize the sum of a bunch of costs. Now we've got the sum, we're going to have cost every month, so we're going to use the sum operator to denote cost for every month. We're going to sum, this I refers to months, so we're going to sum over all 5 months. So I goes from 1 to 5. And then if I put what the cost is for each month, it's going to sum over the cost for all 5 months, and that'll be our total cost. And so first maybe I'll take into account good 1. So the cost of producing good 1 in period 1 is just going to be C1. We said that is the cost of producing good 1 in month 1. We're putting an I subscript because we're just letting I be anything. I can be 1, then in the next summation I can be 2, in the next summation I can be 3, and so on. We're multiplying that, the per unit cost, times how much we actually produce, XI1. That's the cost of producing the good in any one month. We also have holding costs if we have ending inventory. And the cost of holding one good, 1 unit for 1 month is H1I. And the amount we hold of good 1 is I1I. And so those two terms there are going to tell us the total cost of producing and storing good 1 in any one month, in month I. And now we have 2 goods, so now we need to have a second term for the second good. And it's going to be exactly the same, we just changed the 1 to a 2. And of course, in our spreadsheet, that whole summation is going to be one whole sum product formula. We've got a summation, and we're summing products. That's a product, that's a product, that's a product, that's a product. And then number 4 says, what are the constraints for this problem? Well, first we have demand constraints. And whenever I'm deriving this one, I remember I say, okay, I know this has to count for demand and it has to tell Excel exactly what inventories are. And I know that the inventory equation is going to go something like this. So if I take good 1, I say the amount of good 1 we have at the end of the month, in any month I, is going to equal the amount that we started with, the amount in the previous month, I minus 1, plus the amount that we produce minus the amount that we sell. So ending inventory is just how much we start with plus how much we produce minus how much we sell. But I look at this and I know that the I1s are decision variables and X1s are decision variables. And when I set up my constraints, I always want the decision variables on the left-hand side and my parameters on the right-hand side. So I'm just going to rearrange this a bit. Set a minus D1. So that's our demand constraint for good 1. And then we're going to have another one just like it for demand 2. Oh, there's one other thing I want to put here. It may seem obvious to you, but sometimes it becomes very important to say this. We say that that constraint must hold for all I. Meaning that constraint is just listed for the ith month, and we're saying it needs to hold for every month. And then one new constraint that we have here that you got to figure out how to put in. We're producing 2 gums, but our factory floor only has so much space. And there's a limit to how much of any one gum we can produce, a limit to how much of any total amount of gum we can produce. And what we say there is like up at the beginning, it says the total amount of gum produced in any one month cannot exceed 900. So all we're saying there is that in any one month, an ith month, the amount of gum 1 we produce plus the amount of gum 2 we could produce must be less than or equal to 900 for every month. So in any one I, amount of gum 1 we produce plus the amount of gum 2 we produce has to be less than or equal to 900. So that's an inequality constraint. These are equality constraints. And of course, in these sheets, I'm giving you the value of all the parameters, all the C1Is, C2Is, H1Is, H2Is, things like that. And I want you to go in to this spreadsheet. Feel free to talk among yourselves, ask for help. I'm not necessarily going to tell you exactly how to do it, but I'm going to do one of those annoying things professors do where I try to make you think about it. You resist, and I make you think, and we hate each other for it. And try to make the spreadsheet that's going to reflect that model. Of course, you've got the old spreadsheets that you've done, and you can look on that and see how you structured it in the past, and that'll give you a really good indication. One thing you do want to set it up where in your constraints, it's like this, where you have left-hand side here and right-hand side there. And so what I would do, you've got your spreadsheet from last time. It's even on the web, on Canvas. Look at how you constructed it when it was just one good and set it up like that first. You'll need to put in what these cost numbers are, see if you can get it running, and then add another constraint to it and go on like that. All right? Okay, get started. You'll probably just have this class to do it, and you will need to get it built. So work hard, ask questions, look at each other while rolling your eyes. Okay, and just let me know if you need help. And so at home, You just got to try to build it yourself. Let me know if you have any questions and stuff. We'll email if we need to. I don't know how hard this is going to be for you. We'll work it out, okay? And yeah, that's enough. And so bring up there's a new worksheet that we will get to a little later, but bring up your Excel spreadsheet from last time. We're going to finish that. I hope what we did last time, where you had to try to construct some stuff on your own, gave you an idea of how much you understand what type of model we're trying to build and how we go about building it. And after we're done with this worksheet, we're moving from production to transportation. And you know, I think this last 2 weeks, all we've been doing is building these models to figure out how much we should produce each month. But this isn't an operations management class. I'm not actually really concerned about that. I'm just using that because this is an example we talked about earlier, and I'm wanting to help you understand how optimization and linear programming works to begin with, because once we move from here, then we're going to start using these same models to answer transportation decisions, like where raw materials should come from, through what distribution centers they should go through, and which trucks should carry which products to which retail stores, that kind of thing. And it uses the same type of model, but they're more difficult. There's not that difficult, there's just a lot more notation and stuff. And so I'm starting with this as a way to make sure once we start the transportation models, you understand it better. Okay. And we're going back to that spreadsheet where we're saying, okay, now we're producing 2 gums. We have to meet the demand for both gums, decide how much of each gum to produce each month. And we have this other constraint that we can only produce so much gum in 1 month, and the total amount of gum 1 and gum 2 we produce, the sum of those two cannot exceed 900. Now, wherever you were, don't worry about however close you got to finishing last time, because you can do this. Go down to your spreadsheet and go to the sheet. It says 2 gums, at least on mine, and right click on it and click unhide. And then unhide the sheet that says 2 gum solution. Okay. And this will be a model that is mostly ready. But you'll see there are some errors there. Let's see. You'll want to, okay. You'll see the objective function has like an error, and the left-hand side of our constraints has an error. And that's because we have 2 sheets here, and there's really no name for the decision variables in the second sheet. And so whenever we create a new sheet where we're adding stuff to it, we're always going to change our names of variables. And so I want to come here, I want to select all of our decision variables right here. Production of gum 1, inventory of gum 1, production of gum 2, inventory of gum 2. And by the way, when you really should want to, at the end, by the time you graduate, not really using the mouse for much at all in Excel. You want to be People use Excel a lot, don't use the mouse much. And so if I'm wanting to select all this, everything here, I'm starting at the first thing. I'm going to hold down Control. I'm going to hold down Shift. Well, let me say it like this. So we're starting there. If you want to select multiple things without the mouse, you just hold down Shift and use your arrows. If you wanted to scream from the beginning here to the end there, all you do is you hold down Control and hit the right arrow, and you scream to the right. If you want to scream to the left, hold down Control, hit the left arrow. And so if we want to highlight all of those decision variables and do it fast, screaming to the right, because you can have models in spreadsheets like this where there are like 800 decision variables. You hold down Control because that's going to help you scream. You hold down Shift because that's multiple select, and you hit the right arrow and boom, You get them all. We're going to name those bad boys DECVAR2 for decision variables 2. DECVAR2. 2 for the second spreadsheet. We see the objective function looks kind of messed up, and you see in the sum product formula it has DEC vars. That's not the name of our decision variables, so we just need to change that formula from DEC VARS to DEC VAR2. And it'll highlight, and it looks like once we highlight, it does highlight all of the decision variables and the cost variables. So hit enter and everything looks cool there. I'm going to come check these constraints. I'm just going to go ahead and screen to the right here by holding down control, hitting the right arrow, bam. We have this left hand side there. I look at that formula and that problem is the same thing. And the sum product has DEC VARS. We want it to say DEC VAR2. And once that's fixed, we can copy and paste that all the way down. And to do that without scrolling, the mouse is for weak people. The mouse is for ag leadership students and animal science students. This is ag business. Okay. I want to copy and paste this all the way down, so what I do to copy, Control C or Command V. Oh, and by the way, whenever I say on the PC Control, on the Mac, that'll be Command. Okay. So Control C or Command C for copy. Hold down Shift for multiple select. Just scrolling down a little. Control V or Command V for paste. Hold down Shift for multiple select, Control V or Command V. Everything looks good there. Okay. We good, or am I moving too fast? I need to help somebody. Let's review for a minute. You can see I have the scroll lock down. I'm going to remove it because I want to freeze panes, unfreeze panes. I'm going to freeze panes there. I think most all of you got this first block built, your demand constraints for good 1. And those demand constraints, we've been working on those for 3 lectures now. But, you know, this is just where we're saying that demand, right-hand side, demand for gum 1 in March must equal, let's say April. Demand is 300 in April, and that must equal, there's nothing on the gum 2 here because we're just talking about gum 1, minus inventories in April, plus ending inventories in March, plus production in April. And again, all that is saying is that ending inventories in April is ending inventories in March, plus production in April, minus demand in April. That one constraint tells Excel what inventories are, So it can choose the optimal inventory level, and it's telling itself that however much we start with, and we have to meet demand. Have to have at least enough to meet demand, and whatever we have in excess of demand, that's ending inventories. There's an identical constraint for good 2. It's all zeros under stuff for good 1 because this is just regarding good 2. And it has the same pattern of 1s and negative 1s under good 2. And one reason I think you're seeing we like to organize our model like this is because there's usually patterns in these matrices, in these 1s and zeros. It makes it easier to fill things out, but more importantly, it can make it so much easier to debug the program. And whereas demand for good 1 was 300 in each month, we have a different demand for gum 2 in each month. In March, we plan to sell 300. In April, we plan to sell 500. May, June, July, we plan to sell 100. I'm writing something here, but this is something you already have on your worksheet from last time. And then we have this other constraint where we say on our factory floor there's only enough machines in a room to produce a certain number of gum. So in any one month, the amount of good 1 we produce plus the amount of good 2 we produce must be less than or equal to 900. Can't produce 500 units of each gum because there's just not capacity for it. You can imagine a company that actually has like 30 different types of gums, and you can see how these models can really help you make decisions about how much you should be producing. Well, notice, like, if you think about how we want to incorporate that constraint in our model, and by the way, I like to add this. What does that mean? What does this symbol mean? I wouldn't blame you if you don't remember. I'm just curious if you do. Brock's pretending like he knows. Does anybody actually know?
It's like everything.
Yeah, for all. For all I. For every month. I'm sorry, but I was uncalled for. I shouldn't have attacked you like that. But you're tough, you can take it, right? Yeah, a man named Brock can take a little poking. All right, so we think about how this is going to look under there. We have this equation, right? And it's like 1 times x1i, so we kind of know there's going to be a 1 underneath x1i, and then plus the sum product is always summing things, so there's going to be like a 1 under x2i. And thus, if you look at how it's laid out, let's take March. Here's our production constraint for March. There's a 1, and you can, I'm going to change my freeze panes just to make it easier for you to see things. For March, we've got a 1 under production in March, so that's going to be like 1 times 600. Because right now it's saying produce 600 units of good 1 in March. And there's zeros here because those are for different months. And on this row, we're just talking about March, where I equals 1. And then another one's going to show up right here, again, for March for gum 2. and zeros elsewhere. And we're saying the sum of that should be less than or equal to, there's no equal there, it's less than or equal to 900. If we look what we have for April, there's a 1 under April of good 1. There's a 1 under April of good 2. Zeros everywhere else, saying the amount of gum 1 produced in April plus the amount of gum 2 produced in April should be less than or equal to 900. And maybe I'm going to check and make sure this, these formulas are working right. So let's check this 100, see if it's got some product formula there. When I look at everything, what it's highlighting, that looks right, but sometimes I like to go in and manually inspect. So this 100, if it's doing it right, that's saying we're currently producing 100 units of gum 1 and gum 2 in May. Let's see if that's the case. Right now, we're producing 100 units of gum 2. No units of gum 1 for May. So yeah, total gum production is 100. That formula looks right. We're now going to solve this. After we solve it, I'll be glad to come around and take a look, see if you have any questions about anything. And let's make sure we're doing our question right. So we're still doing the worksheet for March 23rd. Where we're taking these, where these are the data. This is telling us what production costs of each gum are, what storage costs are, and what demand is. So we want to make sure that these numbers are correct in the spreadsheet. And so I'm going to check these cost numbers, 5, 10, 15, 17, 5, that looks right. Shree, that looks right. Then we go tens, then we go shrees. Demand should be 300 every month for good 1, then 300, 500, 100, 100, 100. This 900 should be, okay, everything looks good there. I'm going to solve. Data, solver. And I'm going to, yours might already be set up for it, but I say let's hit reset all. And so we can go through the solver dialog box again, make sure we understand it, because repetition is good. Set objective function. Our objective function is total cost. Do we want max, min, or a particular value of total cost? Min, right. We want to minimize that by changing cells or decision variables. So I'm going to select all those, hold down control, hold down the shift, right arrow, boom. Subject to the constraints. All right, add a constraint. We've got our demand constraints for good 1. That says this left-hand side must always equal this right-hand side. All right. Let's add another constraint. This left-hand side must always equal this right-hand side. Okay, looks good. Let's add another constraint. This left-hand side must be less than or equal to this right-hand side. This particular instance using mouse is not a sign of weakness, or I wouldn't have done it. We hit OK. Things look good. Yeah, we're choosing simplex LP. Yeah, we're checking this because the things we're choosing should be positive values. We don't produce negative gum and we don't hold negative inventories. And so let's solve it. And it's probably just going to return us the original thing we had. I think it was set up where it already had the original solution. I'm going to go in anyway. I'm going to change all these to zeros just to have it start over, see if we get the same thing. Solver, solve. And so, you know what it's telling us there is we want to produce most of our good one early on. Everything of gum one we need for May, we're going to produce early in March and April, because in May we're going to be producing only gum 2. And we're doing that because there's smaller production costs for gum 1 in March and April. Okay. Did anybody run solver and not get this solution? Let me come around and help.
24,500.
Might just be checking your cost and holding costs again. Make sure those are entered right. In the cost per unit, no, the 5, 10, 15, 17, 5. Well, if you didn't change any of them, they should probably be. Are you getting the same solution I'm getting?
Yeah.
Hold on a second. Mm-hmm.
Like, shouldn't the production cost be here? And the storage cost be here?
Yeah.
Those be flipped?
Yeah. Did I have it not right? Oh, yeah. Okay, Smarty Pants Sarah found an error. Thank you, Sarah. I entered these 3s as inventories instead of production cost. So I had the numbers wrong. C1 and C2 are per unit production costs. So for good 1, it should go 5, 10, 15, 17, 5. That's right. Production costs for good 2 are 3s all the way across. 3, 3, 3, 3, 3. Because this is quantity produced is multiplied by the per unit production cost. My holding costs are given by these H's. So the holding cost is always 10 for good 1, always 3 for good 2. Maybe because good gum 1 needs to be packaged in a bigger package, it needs more protection. And so it takes up more space, so storage cost is higher. And so storage cost is, for good 1, is always 10. Storage cost for good 2 is always the 3s. And that's already right. Okay, so I've got that fixed. Solve it again. And this leads to a relatively simple solution that just says we produce however much of each gum we need for each month. So we don't ever need to hold inventory or anything like that. Okay, so now with this, did anyone run the solver and not get that solution?
I'm not getting what you're getting up there.
Let's see your computer real quick. Anybody else not get it? Okay, I think it's that your objective function referred to DECVAR, not DECVAR2.
Oh, okay.
So run it again. Okay. 300, 600. Okay, see you later, Steve. We understand completely. Yeah. We've all had those problems before. You're not the only one. Good luck with it. Drink lots of fluids. Something looks, storage cost. Okay, everybody got this? And so let's do, okay. I don't want to keep that solution because it's not interesting. I think when I actually ran it, I had the numbers wrong in the beginning, and I thought it was interesting. So what I want to do, I want to have a solution where we're actually storing some stuff. So let's do this. And we'll write this on the worksheets in just a minute, but let's just do this on the sheet for now. Let's change holding costs for every good in every month to just 2. So holding costs in every good in every month is just 2. Holding costs every good every month is 2. And let's rerun. Yeah, I like that better. So what's going on? Did everybody get that? No?
Yeah, so I got the 18,000.
Let me see your computer. I like that setup. Is that how they do it in the finance department? Okay.
Yeah, when you got 18,000 for your answer, I got that.
Oh, you need, no, we changed it to 2, right? Yeah, 2. Usually when there's something wrong, there's often something wrong with these diagonals. Those look right. Those look right. 900. Oh, you don't have the other constraint.
I put it in solver though.
Oh. Well, that's not adding production of both goods. That's adding production and inventory of both goods.
Oh, okay.
So you're summing production and inventory and production and inventory.
I see.
That'll teach you to try to do things differently than I'm doing it up there, won't it?
boy.
Yeah, mine is messed up too.
What's that? Yours isn't working either? Here, let me. Anybody else not getting it? Tell me if you're not. Okay.
What was the problem there?
You were using a nonlinear solver, and in a nonlinear solver, that's for problems where you don't really know if there's a solution.
Oh, okay.
So when it,
Oh, I think when we reset, I was so used to not messing with that.
Yeah.
But then whenever we reset it,
yeah, and so when it doesn't know if there's a solution, and when it gets to something that seems like a solution, it'll say good enough. It's kind of like y'all on test,
okay.
right? But with the simplex, it knows there's a solution, so it does not stop until the algorithm's complete.
Oh, okay. Thank you.
Yeah, so that was a case there where he had a nonlinear algorithm instead of the simplex algorithm. All right, everybody good? Okay, so let's put those as answers. What we're going to do here, we're going to go to our worksheet. And in here, we're going to put, after setting H1I equal to H2I equal to 2 for all I, because we've got this new solution where all holding costs are now 2, and now we're going to put that solution. So what our solution here is doing, it's saying, okay, production costs for good 1 are lowest in March, and holding costs are pretty low too. They're only $2 per unit now. And so for gum 1, what we'd really like to do is produce as much as we can of gum 1 in March and hold it over for other months. But we have a problem that we need 300 units of gum 2 as well, because we expect people to buy 300 units. And we have a production capacity constraint of 900 units. And so it finds a solution is, okay, so it says in March, produce just what we need of gum 2 in March and put the rest of the capacity solely towards gum 1 because costs are lowest for gum 1 in March. And so that's what it's doing. 600 plus 300, that's 900, that's our factory capacity. That's as much as we can produce. And so we are holding inventories of good 1. We never hold, each month we only produce enough of good 1 to meet our demand. So there's never inventories of good 2. You can imagine all kinds of different constraints you could put under here. Maybe there's an inventory constraint. Your warehouse is only so big. Maybe maybe you can't actually hold 400 units. Maybe you can only hold 300 units. And so you need an inventory constraint in there as well. All different kind of things you can imagine we put here. What we're going to move next to is, and this is where we go to the new worksheet, and I think this is like the last, the last feature of linear programming we're going to introduce. And it's actually going to take us a little away from linear programming. If you look at the whole structure of this model, you see it's called linear programming because it's just summing up stuff. There's some multiplication in there, of course, but it's linear multiplication. This number times this number plus this number times this number. And so it is using linear algebra. And we're able to do that because everything had a per unit cost, but of course in real businesses, sometimes you have things called fixed costs, where you have to pay this one lump sum no matter how much you produce. Well, that's not linear anymore because now you produce this one cost regardless of whether production is 1 or 2 or 3 or 4. That's what we're going to add in here. It's actually kind of easy to add in. It's going to be really important for transportation models because one thing these models are used for is to say, should we open a distribution center in Stillwater, Oklahoma? Walmart's always making decisions about where do we locate distribution centers? Should we open a new one? How much money will it save us? It's hard to answer those questions without some kind of model like this. And so we're going to introduce fixed cost into the production decision, mainly because we're preparing ourselves for dealing with sophisticated transportation models. Okay, and so now let's go to the worksheet for today. The one that says 325 at the top. Did anybody not get one? This is going to be, we're starting off with the same model we've been dealing with. We're just adding stuff to it. So this is partly a review and then adding one more thing. And I think what we're going to do is we're going to do it conceptually and wait till Tuesday and have you actually build it in it. Okay. Okay. So it's the same model as before, except we have one other thing. So exact same model as before, one other thing. Anytime we produce gum 1 in any month, something special happens. Gum 1 is special. When we use the machines to make this gum, it has to be calibrated differently because the ingredients are different. And so whenever we produce a gum 1 in any month, we have to pay engineers a fixed cost to come in and calibrate the machines. And so for that reason, Anytime we produce gum 1 in March, we pay a fixed cost of $1,000. Anytime we produce it in April, fixed cost of $1,000. And it doesn't matter how much we produce. If we produce 1 unit of gum 1 in May, we pay a fixed cost of $1,000 in addition to all those other costs, even if we only produce 1 unit. If we produce only good 1 throughout that whole month, we still pay that fixed cost of $1,000. This is paying the nerdy engineers to come in and calibrate the machines. It takes on maybe 30 minutes to do it, and then we produce however much we want with it. So now we've got a fixed cost in there. It only applies to gum 1 here. And the way we're going to build this, it may not be, once you see how it's constructed, then it's obvious to you how it works. But this is also one way, this kind of model, it seems like something, you just need a mind like a computer to construct, but that's not actually the case. To build really sophisticated models, linear programming models, you need to have a pretty creative mind about how you introduce things into constraints. So setup's the same. I is 1 or 2 or 3 or 4 or 5, denoting March, April, May, or June. There's X1 and X2, telling us how much we're going to produce of each gum in any given month. There's H1 and H2I, telling us how much it costs to store in any month. There's I1I, telling us how much, where we decide how much of gum 1 we're going to store in month I. C1, C2 per unit production costs, D1, D2 the demand for each gum. Because this is an extension from the previous worksheet, there's still the capacity constraint of 900 total units, but now we have this new variable, Y1I. There's no Y2I, just Y1. And this one, Y1I is going to equal 1 anytime X1I is greater than 0. And if X1I is equal to 0, Y1I is equal to 0. So this is just a variable that tells us, and it's a decision variable, and it tells us whether we're going to produce, it equals 1 whenever we're producing any of gum 1 in month I. It may seem redundant to you because you think, well, if we know X1I is greater than 0, don't we already know we're going to be producing that gum? Why do we need this other variable in there telling us that? It's because we need it to incorporate the fixed cost and to have it reflected in the constraint. So we're adding a new decision variable that may seem redundant to you conceptually, but is absolutely necessary for the spreadsheet to work, for the model to work. In 1, 2, and 3, we're going through these same questions we did last time. We have our decision variables. The decision variables are similar to last time. We just have one new one. We're deciding how much of each gum to produce in each month, how much to store in each month, and whether we're producing gum 1 in any particular month. That is a new decision variable. So we're letting Excel decide, are we producing gum 1 in March? Are we producing it in April? Are we producing it in May? Are we producing it in June? Are we producing it in July? And we got to set up the model such that Y1I equals 1 anytime X1I is greater than 0. We know that, the spreadsheet doesn't know that, so we have to tell it that in a constraint. What are the parameters? Remember, those are numbers that are just given to us that we don't choose. The model doesn't pick. It's taken as exogenous, as fixed by the spreadsheet model. And those things are the cost of production, the holding costs, and now we have this new cost, new parameter, F1I, the fixed cost. The $1,000 charge, the fixed cost charge, whenever we produce any amount of gum 1 in month I. So far it's exactly the same, except now we have a Y1I, which is binary, 0 or 1. We have F1I, the actual fixed cost. What is the objective function for this problem? The objective function is going to look the same, except now we have a fixed cost, so it needs to be in the model. Our objective function needs to reflect that fixed cost. And so our our objective function is, we're summing over the cost, I equals 1 to 5, summing over the cost for all 5 months. And so within that bracket, I'm going to have the cost for each month. The per unit production cost of gum 1 times the amount of gum 1 we produce. The holding cost of gum 1 times the amount of gum 1 we store. The per unit production cost of gum 2 times the amount of gum 2 we produce. The per unit holding cost of gum 2 times the amount of gum 2 we produce. And before, that was all that was in our objective function. And these are all variable costs. It's a per unit charge that depends on how much we're producing or how much we're storing. Now we've got that fixed cost. So we know that we need a charge of F1I. Anytime that $1,000 charge, we need that to be charged to the objective function anytime we produce gum in month I, anytime we produce gum 1 in month I, and anytime we produce gum 1 in month I, that's indicated by Y1I. And so that's why, even though Y1I may have seemed redundant, we need it because we need that to be 0 or 1 in the objective function to flip on fixed cost or not. And so the rest of most of the constraints are going to be the same, but now we need to add some kind of constraint to Excel that makes sure Excel knows that Y1I equals 1 whenever X1I is greater than 0 for every month. Okay, most of the constraints again are going to look the same. I'm going to run through them again. What are the constraints for this problem? Okay. I wouldn't write what I'm about to write. I'm telling you how I always start off with the inventory constraint. I always, when it comes to the inventory and demand constraint, it's easier for me to start with the equation that says ending inventories of good 1 equals whatever you started with, ending inventories from the previous month, plus whatever you produced that month, minus however much you sell that much. And then I say, I know that D1I is my parameter, not a decision variable. I'm going to want that on the right-hand side. So then I change this equation such that D1I is on the right-hand side. We're going to have D1I equals and then it's going to be the same thing for good 2. We just replace all the 1s with 2s. And so all I on the each of those, so for each month. So that's where we had that first block of constraints. 1 row for March, 1 for April, 1 for May, June, and July, done to reflect this equation. And then we had that similar block, but for good 2. We then had our production constraint. That total amount of gum produced could not exceed 900. So we said X1I plus X2I has to be less than or equal to 900, all I. You could imagine if we had a warehouse constraint of 500 units, it would be I1I plus I2I is less than or equal to 500 for all I. And again, this is the same as last time. Now we need that constraint so that Excel knows that whenever we produce gum 1 in a month, we have to pay a fixed cost. Whenever X1I is greater than 0, Y1I equals 1. I will go ahead and I'll add this. We have this variable Y1I is binary. And that's you can add that constraint in Excel real easy. You'll see. We know that Y1I is binary, but now we need to link the relationship between Y1I and X1I. Okay, so let's think through a little bit how we would do this. The first person to ever add this constraint, they said, okay, we're going to have a relationship between Y1I and X1I. So something like this. We know what X1I and this Y1I. And we know that Y1I to start with is only going to be 0 or 1. And so we need it such that if X1I is 0, Y1I is also going to be 0. But if X1I is any positive number, let's just say 100, Y1I has to equal 1. And then the person had to think, okay, how do we make sure that relationship always holds? And then they said, okay, what if we had some kind of constraint that always had to be greater than or equal to 0? such that whenever this is 0 and that is 0, it's greater than or equal to 0. Actually, it's going to, I think we're going to want to set it up like this. We could do it anyway, but I like setting it up like this. But we also want it such that whenever this is a positive number and that is 1, it's always going to be less than 0 and never equal to 0 exactly. It turns out that's pretty easy to do. Let's let m be some big ass number. This is a big old number. Has to be pretty, it can be too small. I don't think it can be too big. Some big old number. What's a big number, Brock?
1,576,000.
That is a big number. Make sense, Gavin?
Yes, sir.
Okay. Glad y'all are keeping up. Well, what if we did this? Let's see what this would say. Okay. So this constraint has to hold. The amount of gum we produce in any 1 month minus big ass number times y1i must always be less than 0. And then you also have to remember that Excel is never going to want y1i to equal 1 unless it has to. Why is that? Excel is not going to want y1i to equal 1 just for no reason. Why?
It's expensive.
Yeah. Excel is trying to minimize cost. And if it sets y1i equal to 1, it's got to pay that fixed cost. So it doesn't want y1i equal to 1. Excel doesn't want to, just like you, just like the company, Excel doesn't want to pay this fixed cost. And so if this number is 0, x1i is 0, Excel is going to want this, y1i, to also equal 0 so it doesn't have to pay the fixed cost. It could say y1i equals 1, and this thing would be less than or equal to 0, but then it has to pay this fixed cost for no reason. So instead, if we're not producing any of gum in any of gum 1 in month I, it's not going to want to pay that fixed cost. It can set that equal to 0 as well. It minimizes the cost, and this constraint is held. It's still less than or equal to 0. But then suppose we need to produce gum 1 in month I. So this needs to be a positive number. Well, then the only way that can be a positive number is if y1i is also 1. Because if x1i is 500 and then y1i is 0, the left-hand side is 500, and that's not less than or equal to 0. So if x1i is positive, Excel has to make y1i equal to 1. And then this equation will still be satisfied. It's still less than or equal to 0 because this m is a big-ass number. And that's actually all you need to do. That one constraint right there, that and the fact that y1i needs to be binary is all you need to do to make sure that fixed costs are incorporated correctly into the model. And so the last constraint we add to number 4, we need to say that x1i minus m y1i is less than or equal to 0 for all I, where m is a big ass number. And maybe you can already see how easy that constraint is to put into the model. You're going to have y's now as your decision variables. You're going to put a 1 in front of the x1i's and a negative m in front of the y1i's. You're going to tell Excel it has to be less than or equal to 0, and Excel is going to work its intellectual magic. See, that's kind of creative. There's some creativity there. Sam, don't even act like you're not impressed. You know this is pretty cool. You just won't say it. All right. And next Tuesday, we're actually going to implement this on the sheet. And that's all for now. Have a wonderful weekend. Yeah.